Greetings, everyone. This is Eric Andelin, Senior Workflow Advisor with SimActive, and you're joining me for my interview with Yovist Taufan, founder and director of Quantindo in Indonesia. And today we're going to talk about fixed-wing drones. Are they better than multi-rotors? And now I'd like to introduce my guest. Yovist, say hi to everyone.
Hello, everybody. Hello, Red.
Great to have you. I know we're on two different sides of the world, so it's morning for you and evening for me. But always good to chat with someone about drones and drone technology. So good to have you on board. So give us a little information about yourself and the company and what you guys do.
My name is Yovist Taufan, and my company is for, distributor and brand ambassador for Quantum Systems, GmbH from Germany, and we are focusing in testing Trinity in Indonesian soil. So we are focused on sales in the early years, and now we built some new services company, aerial services company that focus on photogrammetry and 3D mappings.
Very cool.
That's all. Now, that's what we do, and we already sell Trinity in Indonesia is from 2018, and now we have many evolution of products. Because technology is changing, even the sensor. Even the sensor. Now the sensor is more high quality and more bigger data. And we need more bigger space to process the data.
Yeah, absolutely.
That's a little from Indonesia.
So I will say that I've actually been working with the quantum folks for quite a bit. Here, obviously, with SimActive, we run into folks that have quantum systems all over the world. And I actually got to work with Nick Oniello, who I know here in the US. He's a great guy. I don't know if you're familiar with him, but we've talked about all kinds of things quantum. And in this conversation, we're going to talk a little bit, again, I said about fixed-wing drones and are they better than multi-rotors? Because back when we started in this whole drone business years and years ago, it was drones and DJI multi-rotors and things like that. And they're really good for mapping small projects and things like that and video production and so forth. But we've really seen a movement towards fixed-wing drones with the quantum systems and the Wingtras and things like that. And I mean, honestly, it's probably because they capture bigger areas. It's things like that. But I mean, tell me about your experience. And before I get to there, I just like to say that some of the topics we're going to cover for folks are advantages of fixed wings over multi-rotors, projects that benefit from fixed wings, new fixed wing payload options, and then unique processing challenges. So talk to me a little bit about how you guys got to where you were in your business and how you ended up working with quantum systems.
In Indonesia, first time in Indonesia, the drone business is fully monopolized with local drones and Chinese drones.
Okay.
And then DJI comes up. The first thing is DJI Phantom 3, I think. That can be mapping with manuals for small area. And then in 2018, they are starting to build some VTOL. So it's a VTOL session. So and then for now, all of the company, especially in mining, Indonesia mining, they boost up the standard of safety. So you cannot bring the drone with the engine because it can be burned if it crashes, and you cannot use gasoline, and then you must safety if any drone crash is not burn the forest. That's why we start with quantum because in my perspective, quantum is for the safety drones for now. And we pass some tests in some mining company for this safety, like no fire, no fire in the forest if you crash, and no gasoline. It's white area, and sometimes our client is mixed between fixed wing and rotary because in some area, especially in mining, they just need to map only 10 hectares of area, 15 hectares, and they spread anywhere. So that's why they mix Trinity and the copters.
Okay.
That's why I start with Quantum, and now we already 6 years with Quantum with 4 evolution of Trinity. Trinity version 1, F9, F90 plus, and now Trinity Pro.
Yes, yes, exactly.
Yeah.
And you know, I can relate to that. I have worked with companies with drones on both sides. We at one company we had a very large um, gasoline powered drone, multi-rotor, and it was purchased because they wanted to put a lidar system on it, and their safety feature on that drone was a parachute. And
Yeah.
unfortunately, on training day, the drone flew for about 5 minutes. The parachute was not secured properly, and the parachute launched on its own, and they got caught in the rotors and took the whole thing down. So
Yeah.
you're talking about a fairly decent amount of weight coming down to the ground. And then not long after that, we switched to fixed wing drones. And this was before Quantum Systems. It was another fixed wing drone that was also VTOL. But we found that that drone worked very well. So we kind of moved on at that company to just doing work with the VTOL because that's what we kind of did. But let's talk a little bit about one. You mentioned that, I mean, where you're at, the type of mapping you're doing, and the authorities you're working with. The issue is things like fires. You don't want a
Yes.
drone coming down and causing a fire in the middle of nowhere where somebody can't get to it and it's going to spread pretty
Yeah.
quick. Yeah. Yeah.
Yeah. Because if in Indonesia we have some regulation. So if you use cheap drones with engine or gasoline,
Hmm.
it crash. So you must pay money maybe 10 times or 20 times the price of the drones.
Yeah.
So that's the regulation. Even in mining company, if they have some damage in the
Hmm.
mining, so government will suddenly take reaction and give you fine,
Yeah.
or maybe he will cut your permit to the mining or the forestry.
Yeah.
That's why now it's safety, but sometimes our client needs some drones that can map a larger area in one flight.
Hmm.
That's why some of companies still using in Indonesia. We have one company named Sinarmas. They are still using photogrammetry with a small aircraft.
Sure. Yeah.
Yeah, small aircraft. But the problem with small aircraft in Indonesia for now, they just can fly only altitude 400s.
Oh,
Because if they fly up to 400, they have cloud. So
okay.
sometimes photogrammetry is not good with cloud, right? Or
Yes.
small cloud.
Yes.
Yep.
So
That's why yeah, okay.
I was going to say, yes. So we're talking about things that you know, people don't understand maybe necessarily on a global scale, differences in climate, in terrain. All those things affect what is appropriate to do mapping in that specific region. For example, I did a webinar with someone else from India, where they were mapping in the Himalayas. So,
Yeah.
altitude is an issue for helicopters and airplanes, but not so
Yeah.
much for drones. So they were
Yeah.
able to use drones in that reason. And a lot of times people will say, well, why wouldn't you just fly it with an aircraft? And the answer to that is clouds or,
Yes.
terrain, something that would keep an aircraft from just not being able to make it and capture it. So uh, I see you have that same kind of problem.
Yeah, same. Do you know that if you open the map of Indonesia, so we have three regions. Is West Indonesia,
Mm-hmm.
Middle Indonesia, and East Indonesia. And we test Trinity in all the region. If in Sumatra or Java, for the temperature, it still can. It's not too hot
Yeah.
and the wind is not so strong. But in East Indonesia, sometimes some if you're not your model of drones is not like aircraft, you cannot fly, or maybe you can fly, but it's very very dangerous to fly,
Yeah.
especially if you use models like VTail.
Mm-hmm.
So when maybe for takeoff is okay, but for landing you can go anywhere
Yeah.
because VTail with the like this, so
Yeah.
wind can hit you.
Mm-hmm.
That's the problem in Indonesia. So sometimes quantum system develop from that use case. We have many crash in Indonesia for Trinity,
Yeah.
and I already report to quantum. Yeah, my CEO said that if you're not crash, you're not research enough.
Yeah.
If
That's
drone company, you're never crash, so you're not research well.
Yeah, well, that is definitely one way to look at it. So, um, with that in mind, let's talk a little bit about advantages of fixed wings over multi-rotors. So, how do you see that from your perspective, where you're at?
Yeah. So we fixed wing is now we are talking for mapping, right?
Yeah.
Yeah. For fixed wing is yes. Maybe for the benefit is we can map wide area,
Mhm.
and then wide area, and then we can fly high. And then if you do the photogrammetry, you must be stable for the sensors.
Yes.
The aircraft must be stable in speed, or maybe we can control the wind, but we can control the drones.
Yeah.
And but for multi-copter, sometimes in Indonesia we have many clients that still using DJI Mavic for mapping,
Hmm.
and they are using 20 megapixel, and we compare it with fixed wing data, especially for me is for Trinity with 20 megapixel, and we process the data, and then it's different. It's
Yeah.
different in maybe in accuracy. It's different in quality. Yeah, that's the advantage. That's why. But for maybe below 100 hectares, our client, maybe I can recommend them to use copters
Sure. Sure.
because it's overkill. Sometimes it's overkill, like quantum system now publish phase one. We cannot sell phase one in Indonesia because if we fly in 400, it's very big data and overkill for data standard in Indonesia. Because now our standard from government is 10 centimeter per pixel GSD, 15, I think, 1.5.
Yeah. Okay. Yeah.
Yeah.
Yeah. So you're right about that. Whether it's multi-copter manufacturers or fixed wing manufacturers, sometimes they put sensors on those systems that are overkill. The GSD is so small because of the size of
Yeah.
the sensor that it would be great if you could fly higher, but you can't. So it's just a lot of extra
Yeah.
data when all you're trying to do is meet the standards of your government authority or whoever. So
Yeah.
that is definitely true. Um, yeah, with that, I would say I agree that fixed wings will capture a much larger area. and probably more stable than a multi-rotor. And I would assume in Indonesia you've got quite a bit of elevation, so you have no problems with the flight planning for the fixed wings
Yeah,
in those areas.
yeah. I have one use case. Maybe I will send you the video, or you can see it in my LinkedIn, or I will send you.
Yeah.
So sometimes our client uh, using combined lidar from DJI,
Mm-hmm.
lidar from DJI L2 or L1 with our fixed wing, because for fixed wings we cannot scan the narrow, very narrow area.
Yeah. Yeah.
So if yeah, I have the video. Maybe I will send you so you can share. So if the narrow area,
Yep.
very narrow, like this one.
Yep.
So like one.
Yep.
So fixed wing can get the data from here to here. So sometimes our client use multicopter with L1 or L2 or maybe yellow scan.
Yeah.
To check acquisition in here.
Yeah.
So in very narrow areas. So they are combining, so get the full data set.
Yeah, that's fantastic. I mean, use the best tool
That's
to get the
that's
data.
so depend on the sensor. If you use lidar, so you must use fixed wing and multicopter. But if you use, I think if we have some bad experience with our client, but not with Quantum. So they buy engine drones to bring GPR for sensor for mining, and then the factory say you must fly 100.
Okay.
So after one flight they crash, and now I already recommend them you use copters for the radiometric or whatever sensor that in mining use. Because fixed wing, if you fly under 100 in the elevation of narrow area, you cannot get the wind.
Right.
So yeah, if you're pilot, so you cannot get the wind, even it's autopilot. So you must be crashed.
Yeah. No, that's
that's so we can in some area we must in some use we must combine fixed wing and rotor drone. Or multicopter, and even though the fixed wing now cannot doing spray, right? In Indonesia now spraying business is very high, so they are using multicopters.
Yeah, that makes.
So depend what you need for application.
Yeah.
Yeah.
So that would be the next question. It is projects that benefit from fixed wings, and as you said, if it's a spraying application, that's not for fixed wing. That's for multicopter. And maybe if you have a small project, something with a lot of elevation in it, then again, depending on the sensor, if it's a lidar sensor, probably better for a multi-rotor to capture that information. Yes. Because of the environmental conditions you might have to deal with an aircraft, whereas a multi-rotor doesn't have to do that. What other areas do you see your customers or you guys using the fixed wings where the multi-rotors might not apply?
Not apply is I think in the coastline.
Coastline, yeah.
In the coastline. So now Indonesia is a archipelago, right? Many islands. So our government now is trying to map all the coastal area. For Mavic, maybe he can hold the wind, but the quality of the picture is very not good. Yeah. It's not static because in the high wind, so maybe the pictures the picture is not good, so we cannot process the good data. That's why copter cannot apply there if it's for a long area. Can you imagine if one fixed wing they can reach maybe minimum 10 kilometers?
Yeah.
But if you use Mavic or maybe multi-rotor. Maybe they can switch place many times.
Mhm.
And in Indonesia island, no infrastructures. Many of them is no infrastructures to move from take off point to another take off point. So maybe they can use if they force it, they can use the fixed wing, the multi-copter, but the operational cost may be most expensive
Yeah.
than one flight of fish.
Yeah. Yeah.
Yeah, we have experience with one client, uh, different client, but in the same mission. One client have the same project but different area. One client is buying one Trinity, maybe you can say only 20,000 euro, and they buy one project by I think 30 of Mavic,
Wow.
and then 30 of Mavic. So one team is two pilot. Can you imagine operational costs?
Yeah.
Even with one, maybe not just Trinity, maybe they can buy Wintra, they can buy maybe the Chinese Joyo Avi, or they maybe they need only 3% in one team.
Mhm.
So operational cost will be reduced.
Yeah. Do you have
That's
do you have issues there with flying beyond line of sight, or is that not a problem?
yeah, for now, if you're not flying in the military area or near military area, or maybe you fly in the empty island,
Mm-hmm.
you just uh, arrange some permit with the government,
Okay.
and then you can fly maybe 10 or 12 kilometers.
Okay. Mm-hmm.
Yeah. So for now, we are not very strict
Yep.
because we have many of unregulated area
Yeah.
for now.
Yeah.
For
For now.
now, maybe in the future, government step.
Yeah. So
Yeah.
you may not be aware, but I actually live in Florida, and in Florida, actually in the U.S. in general, the big push right now is for mapping shorelines. We're mapping all of our shorelines. Potentially because of water rise from sea ice melt, all that stuff, and also to determine where the sand goes during storms and then how to bring it back and restore things. Is that kind of the
Yeah.
same thing that you guys are doing over there? Is it mapping for documentation, or is it mapping for shorelines for resilience? What are you guys doing there?
Yeah. Uh, Many of application that for now for this year's is starting. So our government now is trying to develop one map policy.
Okay.
First is for mapping, and then now many of business area using drones, sometimes for disaster area,
Yep.
and we have many earthquake here, tsunami potential, and then sometimes it's forest fire.
Yep.
They are still now for forest fire still using aircraft
Sure.
because the drones they afraid that the drones cannot stand with the high temperatures,
Mm-hmm.
and it's very useless if the fire still exists, so the drone cannot get the good map.
Right.
And for the surveillance and military, and now in Papua New Guinea, many of drone there's flying in Papua New Guinea because we still have conflicts there.
Yeah. Sure.
Yeah, we are the same. Same like in Florida, but Florida, I think my friend from Quantum already mapped Florida.
Yeah.
But the difference is we don't have any crocodile in our backyard.
Yeah. Well, you probably have snakes and stuff like that.
Yeah.
But yes, we do have crocodiles. I saw one the other day.
We
Or
have crocodile as well.
I forget, is it alligators or crocodiles? I always forget which ones we have, but we have one of them.
Oh yeah.
And I get corrected all the time, which is interesting. So let's talk a little bit about the payloads that you have in the quantum systems and what options people have. So obviously they have cameras. They've come out with lidar, I think, and other sensors.
Yes.
You know, which ones do you guys use? What are you guys like?
Yeah. For now, we have new sensors, but we still keep the old sensors.
Hmm.
For now, we have phase one. Quantum already released. We can bring phase one,
Yep.
and our lidar before is Cube 240 is with LiFoc. Now we are coming the new lidar 640 with SI,
Okay.
and then
Yep.
the oblique camera that we already test, and we already send the data to SimActive
Yep. Yep.
before, and you can make it as a use case, uh, and then we have Sony ELH for 61 megapixel. So now because we are depending on camera manufacturer, right? For
Hmm.
now, Sony Eric already discontinued, so we must replace to 61.
Yeah.
And now we bring phase one. Phase one before is bigger, now is smaller.
Yeah.
But yeah, that's the new update from Quantum.
Very good. Yeah. So I'm very familiar with the phase one cameras as well.
Yeah,
I'm always happy to see data from a phase one. I know it's going to be good data, especially when it's processed, through SimActive.
yeah,
You can get a great GSD out of it. You can reduce that GSD. You've got a lot of flexibility with how you adjust that image because it
yeah.
basically is a raw format. So that works out pretty well. Um, as far as the oblique cameras, what do you see? What do you see as the future with those?
Yep. So for now, with the obliques, I don't know from another country, but in our Indonesian government now is starting to upgrade the data from photogrammetry. Now they are building like a 3D mapping for
Hmm.
oblique for city information modeling,
Hmm.
BIM, digital twin issue and everything. So they are now testing the oblique. Now we are the first fixed wing drone that test the oblique in Jakarta and in Indonesia.
Yep.
Now we try to test the oblique with the highest altitude, so we can find some recommended altitude for our client. So we already fly 200 meters, like I sent you the data before.
Hmm.
And we fly yesterday in the city 300 meters. Yeah, we for 300 meters we find some problem. Yes,
Yeah.
yes, we find some problem, but I already sent it to Quantum. The problem we have a lot of noise and everything. And now we fly lower. We try to fly lower in 100, and now that's our specialty. But for processing, yeah, that's why we still try to work with another software for processing, including SimActive. How can we manage this data? It's
Well,
big data.
yep. Yeah, that's a very important point because you have five cameras, but one of them is a nadir
Yes.
camera. And that nadir camera can be used. You could turn off all the other cameras, you can disable them. You don't even have to bring them into a project.
Yes.
If the main goal is photogrammetry, use that nadir
Yeah.
sensor. But to the benefit of local governments and agencies, you are capturing oblique data. And as modeling gets better,
Yes.
we'll go from nice looking models, neat looking models to precise models and models that you could measure from. Those things will come down the road, but still looking at a 3D building with the facade mapped so it looks like a real object is still pretty fascinating. But again, you can always create a mapping product from that nadir camera without using the other
You
ones.
know.
Yep. So
Yes, but our government now, I think this year's is starting to many of pilot projects to do oblique
yep.
in a big city in Indonesia in every region. So next year's this oblique camera will be used daily, I think, with our government.
Yeah.
Yeah, because of they need city information modeling for text planning, for maybe for rural planning,
Yeah.
for building, and you know that we have some planning to build an access from Indonesia to Malaysia directly to China. yeah, yeah, that's the maybe the drone business will go forward from there.
Yeah, yeah. Well, I mean, it's always interesting to see um, what users will do with data given the ability to capture it. So the fact
Yep.
that you can capture that oblique imagery, you could use just the nadir in the forward. You could use the nadir in the rear.
Yeah.
You could use all of them. So there's a lot of ways to um, manipulate what your outcome is going to be based on, like you said,
Yep.
altitude. Maybe sometimes it's too low. Maybe sometimes it's too high. You
Yeah.
know, it is with every new sensor. It's a challenge finding the sweet spot where it's going to
Yep.
be most successful. And terrain can change that. Climate can change that. There are a lot of things, but we certainly see the push in that direction.
Yep.
Yep. Um, so okay. So now we're talking about that, and what an oblique camera does is it brings 5 times the imagery for every exposure. So let's talk a little bit about unique processing challenges that you guys have come up against since you've started using the Quantum with the phase one 61 megapixel and with the D2M oblique sensor. How are you guys dealing with those larger data sets?
For now, many of software development is proposing some uh, some services like a cloud system, yeah, cloud system, and then cloud processing. But the problem is Indonesia, if we send data, sometimes the government cannot allow it
Mm-hmm.
for now,
Mm-hmm.
especially in mining because it's a vital object.
Yeah.
And now we still doing like processing with Agisoft, but in Agisoft we must have limitation. Maybe if 300 hectares, we must split it to maybe every small area.
Mm-hmm.
Maybe max is depend on your computers. And with Fish 4D, yeah, we still cannot get best result.
Yeah.
And now we try to make some with another processing. The problem is sometimes if we fly higher, many noise.
Yeah.
So even Fix 4D cannot. My experts say that some of this software cannot detect where is the noise and where is the real pictures.
Yeah.
That's the problem. But many of our client is now still trying to find good software, even the Autodesk, even the
Mm-hmm.
Bentley.
Mm-hmm.
Yeah. Now the advantage is now processing the oblique data
Yep.
with a big area with three, like I said you before, maybe 250 or 200 hectares, right?
Yeah. Yeah.
It's very challenging.
Yep. Yep.
That's with the D2M.
Yep.
Now we're
And
still trying.
yeah, yeah, and that's what SimActive is good for, is for large projects. So
Yeah, no, because we are not looking for good processing. No, just not 3D model. Because our client now need for city information modeling. So this 3D model can input with some information about maybe if if the one building already paid tax or no,
Yeah.
and the tax is correct or no, with the building height and measurement and everything.
Yeah.
That's the output for.
Yeah. So then now you start talking about GIS and spreadsheets and all kinds of things that the output data has to go
Yes.
into for these cities to
Yeah.
work with. Yeah. Yes. That's definitely a challenge. Well, what I would then like to say is, Yovist, I appreciate your time. Thanks for joining us, and we'll probably get into a little demo at the next stage of this conversation. And you said you might send me
Yes.
some stuff, so that would be great.
I will send you the new data, but I will give you new data because in one area you can publish in only north area, because in the middle is national police headquarters
I
and
was gonna say,
everything is
you say
confidential.
block that
So
out.
I will but maybe data from yesterday that I sent,
Yeah,
it's very
very
enough
good.
then.
Very good. Well,
Yeah.
again, when new sensors come out, we often see challenges with them. From everybody who is bringing them on board, and we really like to help the users out and help solve the problems and figure out the best workflows so that they can make the most out of those sensors. So
Yes.
we appreciate the back and forth, and we appreciate the feedback so that in the data sets so that we can confirm that everything is working right as far as our software goes.
Yeah.
So I appreciate that. Thanks again for joining us, and we'll talk soon. So let's go ahead and open up Correlated 3D, and we'll go over some of the things that we've been talking about with Yovist in this interview. Okay, so here we have a project from Quantindo. Actually, Yovist talked about it a little bit as one of their projects. And I know it looks a little confusing right now, so let me turn off some of the information here. Let's turn off the images first, and we can get a better look at the project. And I'll go ahead and reset the view so we're zoomed in. But that is, just a simple feature that sometimes people don't think about all the time, and that is your reset view and your zoom in button. So keep those in mind when you want to take a look at things. Also, you can always go down to the online data and turn that off, and then you can kind of see the results of what you have created. So here we have, just an interesting area in Indonesia, and I'll turn the online data back on. You can basically just see that it lines up well, which is to be expected. This was flown with the Trinity, and it was flown with the D2M sensor, so it actually is the multi-camera oblique, and we can look at those images individually. Again, I turn the camera back on, and as I scroll through, we can see that this is probably the forward camera. Good project setup would show that you've got nadir, you've got your back camera, front camera, left camera, and right camera. So let's turn off all of them. Let's turn off all the cameras except for nadir. We'll turn that back on. And now, as we move through the imagery, we can see those nadir images. And clearly there was some crab in the flight, but there's plenty of coverage so that we can create the photogrammetric products. But again, as you scroll through the flights, you can see those image footprints. So keep that in mind, and we'll turn everything back on here. And another thing we could look at is actually their positions on the screen. So let me turn the DEMs on. And then when we have that set up, we can actually see our footprints. When we click on the images, we can see those footprints in the 3D model. And I'll flip the view here so you can see that and zoom out a little bit. But you can see that image footprint in the 3D model as it's being broadcast down to get an idea of what it looks like. And again, we've got a little bit dirty view here, so let me turn a couple things off so you can see that. let's turn off the orthos and the mosaic in a 3D model, and we can look at it with just the raw DSM. If you zoom in really tight, you can actually see all of the image positions being broadcast down as you look at the images. So something to be aware of. We could click on another image here. And again, now I'm looking in the lower right corner. And if I click on another image, we'll go flip back over. If I click on this one, for example, it's going to give me that image, this one. And again, we can look at it. Having flipped the 3D view, we can look at it there and see that we've got everything we need. Now, what's important here is that you have enough coverage. Now, with a multi-camera oblique camera, you're definitely going to have enough coverage. Again, we talked about 5 images versus just one nadir. Those 5 images are 5 times as larger a data set, so be aware of what you ultimately want to do with this data. If you're going to do just straight mapping with it, you can go ahead and turn off all the other images when you're creating the project, or when you're starting AT, I'm sorry, and process just the nadir images to create a DSM that is suitable for what you're trying to do. And actually this DSM was created from the nadir images alone. And there's a reason for that, just because in this case they wanted a nadir map, so we're gonna go ahead and do that. That's going to be created for them. But if we look at, for example, the DSM that was used to create the model, we can select that here, and you can see the DSM to create the model is just this area. And there's a reason for that, because a lot of these images out here, they fall well beyond the boundary of the model, and therefore they're not necessary. So in order to speed up processing time, you can remove those, and then you can process just the DSM for the 3D model, creating that 3D model. And I'll go ahead and turn off the images again. And now we can see the 3D model. I'll turn off the surface. So let's now take a look at that 3D model, and I'll just zoom into an area here. And we can go ahead and flip the image from nadir to 3D model view. And we can see we've got a nice 3D model of this project area. So, the data set came out pretty well. Like Yovist said, ultimately they're going to want to do, survey grade measurement from this. And I would wager to say that that's, a bit out for a lot of the photogrammetric softwares out there. But again, it's what do you want to use this data set for now? And there are plenty of things you can do with this 3D model, from the point that it's a pretty picture to something that people can do renderings from, all kinds of things like that. And to be honest, the multi-camera oblique system really helps you get a good deep data set to look at. Now, as Yovist and I were speaking earlier, you could do this with a single nadir camera pointing down, one pointing forward and one pointing to the rear. You could do it with single camera pointing down, one pointing forward, and that's it. Or, if you're using something like a DJI where you've got a gimbal, you can just set that camera at, forward so many degrees and do some crossing patterns. I even saw something the other day where somebody was doing circular patterns. Instead of fly to the waypoint, shoot a picture, fly to the next waypoint, shoot a picture, they were actually creating circular patterns around each one of those waypoints. So there's a lot of ways to do this. It's just a question of which is the most efficient and what are you trying to do. So that's just an example of what we would get from the 3D model. We again have the orthos, which should display here in a second. And those are all the orthos which came in, and I'll go ahead and turn off the background information so you could take a look at that. So these are all the orthos for the project. And then ultimately we'll go back to, as you're aware of seeing, the nice color balance mosaic, and we can kind of zoom into these areas and take a look again. And we can see, some nice information again, just from our standard photogrammetric deliverable. You're going to see some good information out of these data sets. Very happy with the results. And I know Yovist is very happy with the results as well. So, let's keep those things in mind when you're working with these multi-camera oblique systems. First, if you're going to create nadir products or photogrammetric products, go ahead and turn off all the other cameras. You're not going to need them. But if you want that 3D model, then you can turn them back on, you can process out that 3D model, and you've got, now an additional data set that ultimately, as we move forward towards digital twins, we're going to start to see more of this type of work. And it's going to take a lot more than photogrammetry software to do this. Again, think of it this way. Think of it, the outputs from correlated 3D can be used, brought into, whatever CAD package you're using, whatever GIS package you're using to produce further output results. And I think, Yovist pointed that out pretty well, is some of the other software that they were working with to create these deliverables. Once again, I think we've covered many of the things that we discussed in the interview. Granted, this isn't one of the largest projects, but it is still a large project. And you can imagine trying to capture this with, say, just such, a system as like an DJI M300. You could certainly do that, but it's going to take you a bit more time than what the average person might want to put up for at these points or at this point. So keep that in mind. And again, this was done with the Quantum Systems Trinity F90 drone, which is, a fixed wing VTOL. And if you reach out to Yovist or you see, some of the posts that they put on LinkedIn, you can see that they supply a lot of those systems in Indonesia. I think we've covered everything in correlated 3D. So we'll go ahead and finish this demo. And I would like to say, for everyone who left a question, we will respond to those as soon as possible. Well, again, I'd like to thank my guest, Yovist Taufan, founder and director of Quantindo in Indonesia. I'd also like to thank those of you that attended the webinar. Again, if you submitted a question during the webinar, I'll make sure to get those answered for you as soon as possible. I'd also like to remind everyone that this webinar, as well as our previous webinars, podcasts, and interviews are all available on our website, simactive.com, where they can be found under the Learning tab. Additionally, this webinar will be converted to a podcast and made available in the next few days. Thanks for joining us. Until next time.